I want to start today's lesson off by doing a warm-up. So please turn to your 3A3 warm-up and take some time to complete numbers 1 through 4, which will be review of what we've done previously. Pause the video while you work on that. Now that you guys have worked through that, I want to kind of talk through my answers a little bit. Here, for the first one, what it's saying is that I am happy when Purdue wins. So saying if Purdue wins, then I am happy. That's written in if-then form. The converse would be switching the hypothesis and conclusion. So if I'm happy, then Purdue wins. Number 2, when I look at this one for 2A, Jimmy got bitten by a dog. Then he worries that other dogs will bite him and is now scared of dogs. So he's drawing the conclusion that other dogs are going to bite him based on previous events, not based on fact or definitions or theorems. Not every dog will bite him, but he has this previous experience that he's basing this conclusion on. Part B says that 2 angles add to equal 100, or 2 angle measures have a sum of 180 degrees. So they're supplementary. That's the definition. If the measure of A plus the measure of B is 180 degrees, then A and B are supplementary. Well, that's deductive reasoning. You're using facts or the definition of supplementary angles to draw conclusions, so that would be deductive. The next one, what can you say about the product of an even integer and an odd integer? I kind of go through just trial and error, so multiply an even and odd number, and what I find is that they are always even. So then when I'm thinking about whether or not I'm using inductive or deductive reasoning to answer that, how I came up with that was just by multiplying a bunch of even and odd integers together to see what the pattern was. So for me, I would have been using inductive reasoning. Now there is a way that you could do deductive reasoning. We have not talked about that in class yet, but you can actually prove using definitions and theorems that in fact no matter what the even integer is or what the odd integer is, the product must be even. So there is a way to use deductive reasoning, but the way I chose to do it was using inductive reasoning, just a pattern of specific cases. All right, so then when you move on to solving the equation, this is what I got for my proof for solving the equation. Here. Our steps are not necessarily going to be exactly the same, but they will probably be pretty similar. So here my first step would be to distribute. So I would get that. That would just be the distributive property. Please make sure you do not have the distributive property of equality. You're not doing something to both sides of an equation. You're just distributing on one side. So this is just distributive property. From there, I subtracted 12 from both sides to get 72, or really added negative 12, which is why I said addition property. You do not have to do that first. You could have combined like terms. So these two steps are really interchangeable. Then I decided to combine like terms to get negative 30x. Now I said distributive property instead of combining like terms because essentially when you combine like terms, it's the reverse of the distributive property. So if you look over here, you're essentially factoring out a negative x. So 24 plus 6 would be 30, where you get negative 30x. So it's the reverse of the distributive property if you're factoring out the GCF. If you said combine like terms here, I would give you credit for that as well. Then I divide both sides by negative 30, but we know dividing by negative 30 is the same thing as multiplying by the reciprocal of negative 30. So you can think of this as multiplying by negative 1 over 30, which simplifies to this. Now, it says to prove, though, that x equals negative 12 fifths. So a lot of us might have stopped here, but we cannot actually stop there. We need x to be on the left-hand side, and some people flip it right away just because we know that that's true. Now, we know that's true, but there's actually a property that says that, and that's called the symmetric property. And that's what we're going to talk about today. So you actually need a 6th step here. In order to make it so that a variable is on the left-hand side, it requires a 2nd step because so far x was on the right-hand side, and you can't move it until you have until you use a property to do so. So that's what we're going to talk about today. When you look at the next page, properties of equality and congruence, we have 3 properties that we're going to discuss. One is the reflexive property, another is symmetric, and another is transitive. And in order to understand this, I found these pictures that I think are helpful. So reflexive, kind of imagine this person is standing here, and then she's standing there again. So it says Jean is the same height as Jean. Essentially, she's equal to herself. Whereas symmetric will say, okay, if Jean is the same height as Pedro, then Pedro is the same height as Jean. They're kind of switching sides. So that's what we see when we're doing the when I wanted to switch sides here, if negative 12 over 5 is equal to x, then x must equal negative 12 over 5. So that's the idea of symmetric property. And then transitive property will say, okay, if Jean and Pedro are the same height, and Pedro is the same height as Chris, then Jean must also be the same height as Chris. So it's kind of this like, if A implies B and B implies C, then I can skip that middle guy, that connector, and go right from A to C. A would imply C. So let me show you what that looks like here. We can talk about reflexive property of equality for numbers, segment lengths, and angle measures. So for real numbers, any number is equal to itself. 5 is equal to 5, 6 is equal to 6, negative 2.3 is equal to negative 2.3. For a segment length, the length of AB is equal to itself. Okay, reflexive property just says that length, that measure, is equal to itself. Now you're also going to see times where it's written like AB is equal to BA. And even though it looks like things switch, you're still naming the same segment, right? AB is the same segment as BA. So even though I wrote it in different ways, it's still the reflexive property because it's still saying it's that length is equal to itself. And for the measure of angle A, the measure of angle A is equal to itself. If I talked about the measure of angle ABC, I could say it is equal to the measure of angle CBA. Again, it's the same angle having the measure equal to itself, even if it's named in a different way. Whereas when we get to symmetric property, it's a little bit different. If A equals B, then we would say B is equal to A. And here, if AB is equal to CD, if the length of segment AB is equal to the length of segment CD, then we would say CD would equal AB. And then finally over here, if the measure of angle A equals measure of angle B, then that must mean the measure of angle B is also equal to the measure of angle A. And these are things that you guys already know, but we now have to have a property, a name for why that's true. And finally, there's a transitive property. See if you guys can complete the sentence right now based on what I talked through up here. Pause the video, try it, and see what you got. All right, so if you're looking at this, transitive property says, if A is equal to B and B is equal to C, then I can kind of connect these guys and just say, well, A is equal to C. Same thing here. If AB is equal to CD and CD is equal to EF, then I can connect those guys and say AB is equal to EF. And finally down here, we got measure of angle B is kind of our connector, our tie between the two, so measure of angle A is equal to the measure of angle C. So these are properties of equality. What I want you guys to do right now is to look down here and try and name what property do you see is being demonstrated. Pause the video and try these three on your own right now. Go. All right, so when I look at this, I'm saying if DF is equal to FG and FG equals GH, then DF equals GH. So this one is equal to this one. That same guy is equal to another guy. So this ends up being our connector, which connects those two. So I get this statement, which is transitive property of equality. Looking down here, angle P is congruent to angle P. Now, a lot of people will look at this and say, well, P is equal to itself, but we're not using equal here. So this is actually kind of a trick question at this point. This would not be reflexive property of equality. This is actually reflexive property of congruence, and we're going to talk about that in a second. Property, but instead of equality, we'll have of congruence. Sorry about the bell. All right, so whether it's equality or congruence is important as we're discussing these problems. So then the last one, measure of angle S is equal to measure of angle T, then measure of angle T must be equal to the measure of angle S. So they switch sides of the equal sign, so this would be symmetric property of equality. They're actually switching sides. It's not equal to itself. These are two different angles, and we're switching sides. Symmetric property of equality. All right, so going back to this idea of reflexive property of congruence, I want you guys to understand there are properties of congruence and properties of equality. So down here, we said reflexive property of congruence. So for example, for any segment AB would be congruent to itself. So now I'm using congruence symbols instead of equality symbols. Well, if I'm talking about segments, then I have to talk about congruent segments, not their lengths. Go ahead and based on reflexive, symmetric, and transitive property that we studied earlier, see if you guys can figure out what the statements would be here. Pause the video and try and write that in right now. All right, so what we're finding here, if you use the same idea that we did before, for reflexive property of the angle, you would have angle ABC is congruent to itself. If you wanted to, you could also change it. Again, CBA would be congruent to angle ABC. Again, because it's the same angle, just named it in a different way, it still means the same angle is congruent to itself. But we're not going to have M in front. We're not going to have measures. We are now saying the angles are congruent. For symmetric property, now you're talking about two different geometric figures that are congruent to one another, but they're switching sides. So segment AB is congruent to CD, then you could say CD is congruent to AB, and same thing with these angles. And then finally, for transitive property, if AB is congruent to CD and CD is congruent to EF, then you got your little connectors here to say AB is congruent to EF. Again, make sure you have the segment bars above these because we're talking about congruence. And then same thing here. Angle B is kind of the connector between angle A and angle C, so that would be our conclusion using symmetric property of congruence instead of equality. So what I'd like you to do now that we have talked through those is now look at this longer list and try and match up the which property is matched with this. For any property not used, I want you to write your own statement. So take a little bit of time right now, pause the video, match these up, and if there's any that are not used, I want you to write your own statement that would demonstrate that property. All right. Now that you've tried this on your own, I'll kind of talk through my thought process. I have the measure of an angle is equal to itself. That's reflexive property. Because it's equality, I know it's property of equality. So reflexive property of equality would be number one. Number two, I have two congruent segments, but they're different congruent segments. When I write it the other way, I switch sides. So that would be symmetric property. Again, it's congruent, so I'm thinking symmetric property of congruence. That would be F. I have one segment congruent to itself. It's the same segment congruent to itself. That's reflexive property. I know it's reflexive property of congruence because I have a congruent symbol and I'm talking about segments. Here, angle J is congruent to angle K is congruent to L, and J is congruent to L. So I have two different congruent statements where I have a connector between the two. So that allows me to say J and L are congruent. That would be the transitive property. I'm using congruent symbols and angles, so transitive property of congruence here. Down here I have PQ is equal to QR, QR is equal to QS, so PQ is equal to RS. Again, I have two statements, and I can kind of smush them together with that guy as the connector to say PQ is equal to RS. So that would be another example of transitive property. This time we're talking about segment lengths and equality, and so it would be transitive property of equality. That would be C. And then finally down here, we have measure of angle X is equal to measure of angle Y. I have two different angle measures that are equal to one another. I switch the sides, and so now that would be symmetric property because I'm talking about equality and measure. That would be symmetric property of equality. That would be A. So now the only one I have left is multiplication property of equality. So at this point, if you've not done so already, try and write a statement that would be showing or modeling the multiplication property of equality. All right, so what I remember is the multiplication property of equality says you can multiply both sides of an equation by the same number. So you have a lot of different possibilities here. You could say if x is equal to 5, then 20x would be equal to, well, I multiply the left-hand side by 20, I got to multiply the right-hand side by 20, would be equal to 100. That would be one example. I could just use variables. I could say if A is equal to B, I can multiply both sides by C. Then A times C is equal to B times C. So really, as long as I'm showing I'm starting with the statement and then I'm multiplying both sides of the equation by something, that is the multiplication property of equality. All right, and I believe that is it for our notes today.